Hello all. In this session, we discuss concept called hill climbing algorithm. So, hill climbing algorithm is a popular local search algorithm, most widely used in optimizing AA problems. This algorithm this algorithm solves the problem by taking initial position and continuously improves that position until we reach the goal. Now this problem is like analogous to human climbing. Suppose a human wants to climb a hill. So, a human is climbing hill. Just imagine, assume he is climbing a hill and it's a blindfolded, means he cannot see things and he has to reach from this start state, starting at the bottom of the hill, and he has to reach on top of the hill. So, when he can't see the things, every step he wants to make every step as a better improvement over previous step, and here he cannot backtrack, means again he can, once while starting the climbing in the middle of the hill, if he says that if I made any wrong mistake I go to the starting position, means it's not possible, no backtrack. A human, he has to go to the top of the hill, and at every step he has to make a correct choice or correct step which is the improvement of previous step. So, when he reach this hill, we say it as he reached a global maximum. Global maximum. But it's not always possible to reach a global maximum, because hills are not always in like this linear. Sometimes hill may go like this. So now human is climbing this hill. So here after reaching that, he thought that I reached my top position on the hill. But actual global, this is not a global maximum, it's a local maximum. Means he, by after reaching, he thought that if I reached the position, means it's not a correct way of solving the problem. So he has to go to the global, means the steps that he choose while reaching this position, he has to choose carefully that he should never enter into this position. He should either, even if he enters the position, he tries to go to the global maximum. So this is one problem while hill climbing, that he may encounter this local maximum problem. But sometimes hills may be in a different position, like a hill is given like this. Here he faces this flattened surface. Flattened surface, that when a human comes here in this position, he feels that his position is secured. He has made his best improvement over the previous. He is not climbing and everything is looking like a flatten. I have reached my hill position top. This is another problem of the hill climbing problem. One problem is local maximum problem. Second problem is flattened problem. And third one is he feel that ridge problem. Suppose here A is there, so he cannot guess exactly. Actually B, he thinks that B is not visible, so thinks that A itself is the goal. So actual B is nearby the some location that looks actual top position of your hill, but some other position looks like exactly like the top position. So these are three problems while climbing a hill, means a blindfolded human, how he has to climb this hill by overcoming these three problems, like local maxima, flattened problem and ridge problem. So how he reach this top position on the hill, the same is analogous to our problem solving in AA also. When we try to solve a AA problem, we also apply this approach of hill climbing. So hill climbing means here every step, next step is the improvement of previous step, and you cannot go back to previous step. Suppose I take one eight puzzle problem. This is starting state, and he has to reach a goal state. General is a goal state, means suppose we start playing a game, not a human being. Suppose AI program wants to solve this problem of 8 puzzle, where you have only one option: either you can move to the right, or you can move to the down, or you can move to the up, or you can move to the left. Now when we solve this problem, first we, as usual, we prepare a state space search of the algorithm, and then I apply a hill climbing algorithm. How I solve this problem? So first what I do, I make a list of possible states. So possible states from this state. So from this state I can move 8 to the right side. So I reach to the position 1, 2, 3, 8, 4, 7, 6, 5. This is one state, and I can move to the another state. Another state where like 1, 3, 2, 8, 4, 7, 6, 5, or I can make another state 1, 2, 3, 8, 6, 4, 7, 5. Now my program tries to find the which state is the nearest to my goal state. So which state may give may take me to the in a possible shortcut way to the goal. It calculates one heuristic function. Like a hill climber, he prepares suppose while climbing the hill, if he feels that some step is improvement, next step is also he wants to the nearby step will be the he tries to go in a nearby step, because that is also improved version of the previous step. So here this heuristic function calculates which of these states nearby resembles my goal state. You can write this heuristic function in any way. My heuristic nothing but estimation function. This estimation function takes me to the goal state. It estimates that if I go to this state, I take only, suppose, the number of moves required from this state to this state. It calculates. Suppose if I take this state, to make this state as a goal state, because the local search algorithm never search for a path. It always, every node is a goal state. So it tries to optimize at every state. Every state can be a goal state. So you see that it does it for how many steps are required to make this state as a goal state. How many moves? That moves is calculated by one heuristic function. So it requires 765 already is there, no less number of movements. The only one position 3 has to change, 8 has to change. Some form means this is what similar. Its heuristic function, suppose it may take 3, it may assign 5, it may assign 4. So like this, from this position again it goes to the different state. Which heuristic gives the, suppose it may, somebody may give one step, some state may give 3, some may give 2. Again this will become the best one. Like this, like a hill climbing means this is the starting position of the hill and this is the top of the hill. Now the problem is, suppose some states may have same heuristic function. My program may give same estimation. Suppose this estimation, this state is also 0, thus this state is also 0 and this state is also 0. Then which state I have, it has to choose. nothing but we reached a local maximus position. Indirectly we reached a local maximus position. So means I have to change my heuristic function to avoid this local maximus position. Like this every problem means once I choose this step I cannot go back, like hill climbing I cannot backtrack, you can go only in forward state. So that means you have to prepare your steps so carefully that improved steps that every step should take you to the top position. This kind of approach we call it as a hill climbing approach of solving a problem. So what are the terminologies we used here? This is like hill climbing. So global maximum means different terminologies we use in this state space H. Local maximum means state better than its neighbors but not overall the best overall. So local maximum looks like a global maximum but it's not a real goal. The global maximum at the best state is the state space where the objective function achieves its highest value. Like in my previous 8 puzzle problem, my heuristic function or objective function give me the exact state where that state matches with the goal state. A plateau is a region where neighboring states have same objective function value, making it difficult for the algorithm to decide on the best direction to move. See, sometimes states have similar heuristic values. We get a confusion which state I should take the decision. That is also that problem we call it as a flat local maximum. So higher region of slope where a ridge is higher region of slope which can look like a peak. This may cause algorithm to stop prematurely, missing better solution nearby. That means sometimes some states look very easy. One step, say like in my 8 puzzle, I thought that only one step is required to get the state, but while solving the problem, it reveals itself with more number of states. Such kind of a problem we call it as a ridge. So a shoulder is a plateau with an uphill edge, allowing the algorithm to move toward better solution if it continues such beyond. At one point of time we reach a state, it helps us to move to the next better position. So these are some terminologies we use in hill climbing algorithm. In next section we solve one block world problem, how we can solve a block world problem using hill climbing. Thank you.